The electrician's statement regarding the meter grounding the panel is partially correct. If the meter is properly grounded to the grounding electrode system, current can flow along the metal conduit connecting the meter to the panel, providing some level of grounding. However, this isn't a reliable grounding method, and relying solely on it isn't recommended. The grounding electrode conductor from the panel to the water heater should be installed per code and bonded to the grounding electrode system at the service entrance. As for the grounding at the meter, the hole in the meter box and the ground rod nearby suggest a grounding electrode conductor was previously installed, but is now removed or disconnected. A grounding electrode conductor should connect to the service lateral and extend through the meter box to the meter, connecting to the grounding block inside. The grounding electrode conductors at the end should connect to the grounding electrode system at the service entrance. Regarding the air conditioning disconnect switch height, the National Electrical Code requires disconnect switches for air conditioners to be at least 6 feet above the ground for safety. The switch should be readily accessible and easily operable for safe maintenance and emergencies. It is recommended that a licensed electrician do the following. Firstly, install a proper grounding electrode conductor from the panel to the water heater, bonding it to the grounding electrode system. Secondly, install a grounding electrode conductor at the meter, connecting it to the service lateral meter and grounding electrode system. Thirdly, raise the air conditioning disconnect switch to the required height. Lastly, inspect and address any other electrical concerns identified during the inspection. The grounding electrode conductor plays a crucial role in electrical safety. It provides a low impedance path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to quickly trip and to energize the circuit. This minimizes the risk of electrical shock and fire. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes, bonded together to form a common grounding point. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in the National Electrical Code Table 250.66. Improper grounding can lead to dangerous situations, including electrical shock hazards, equipment damage, and increased risk of fire. For instance, if a fault occurs in an appliance and the grounding system is inadequate, the appliance's metal parts can become energized, posing a shock hazard to anyone who touches them. Proper bonding is also essential for electrical safety. Bonding involves connecting all non-current carrying metal parts of an electrical system together to create a low impedance path for fault current. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electrical shock. Bonding is typically accomplished using bonding jumpers, which are conductors that connect metal enclosures, raceways, and equipment together. The size of bonding jumpers is determined by the size of the circuit conductors, as specified in the National Electrical Code Table 250.102. Another important aspect of electrical safety is the proper installation of ground fault circuit interrupters, also known as ground fault circuit interrupters. Ground fault circuit interrupters are devices that detect small imbalances in current between the hot and neutral conductors in a circuit. If an imbalance is detected, the ground fault circuit interrupter quickly trips, interrupting the flow of electricity and preventing electrical shock. Ground fault circuit interrupters are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code specifies the locations where ground fault circuit interrupters are required in Section 210.8. Arc fault circuit interrupters, also known as arc fault circuit interrupters, are another important safety device. Arc fault circuit interrupters are devices that detect the presence of arc faults, which are dangerous electrical arcs that can occur in damaged or deteriorated wiring. If an arc fault is detected, the arc fault circuit interrupter quickly trips, interrupting the flow of electricity and preventing electrical fires. Arc fault circuit interrupters are required in many areas of the home, including bedrooms, living rooms, and dining rooms. The National Electrical Code specifies the locations where arc fault circuit interrupters are required in Section 210.12. The height requirement for the air conditioning disconnect switch is intended to prevent accidental contact with energized parts. The 6-foot height requirement ensures that the switch is out of reach of children and prevents adults from inadvertently touching the switch while working in the area. The National Electrical Code also requires that disconnect switches be readily accessible, meaning that they can be easily reached and operated without the use of tools or ladders. In addition to the grounding electrode conductor, bonding, ground fault circuit interrupters, and arc fault circuit interrupters, there are many other important aspects of electrical safety. These include proper wiring techniques, proper overcurrent protection, and regular electrical inspections. It is important to hire a qualified electrician to perform any electrical work in your home or business. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical work is done safely and in accordance with the National Electrical Code. Regular electrical inspections can help to identify potential electrical hazards before they cause problems. An electrical inspection should include a visual inspection of the wiring, outlets, switches, and other electrical components. The inspector should also test the grounding system, ground fault circuit interrupters, and arc fault circuit interrupters. Any electrical hazards that are identified during the inspection should be corrected immediately. Grounding systems are designed to provide a safe path for electrical current in the event of a fault. A fault occurs when electricity flows outside of its intended path, such as when a wire comes loose and touches a metal enclosure. Without a proper grounding system, the metal enclosure could become energized, posing a shock hazard to anyone who touches it. The grounding system consists of a grounding electrode, which is typically a metal rod driven into the ground, and a grounding electrode conductor, which connects the grounding electrode to the electrical panel. The grounding electrode conductor must be sized according to the National Electrical Code Table 250.66. Bonding is the process of connecting all non-current carrying metal parts of an electrical system together. This includes metal enclosures, raceways, and equipment. Bonding creates a low impedance path for fault current, which helps to ensure that overcurrent protective devices will trip quickly in the event of a fault. Bonding is typically accomplished using bonding jumpers, which are conductors that connect the metal parts together. The size of bonding jumpers is determined by the size of the circuit conductors, as specified in the National Electrical Code Table 250.102. Ground fault circuit interrupters are designed to protect people from electrical shock. A ground fault circuit interrupter works by monitoring the current flowing through the hot and neutral conductors in a circuit. If the current flowing through the hot conductor is not equal to the current flowing through the neutral conductor, it means that some of the current is leaking to ground. This leakage current is called a ground fault. Where a ground fault is detected, the ground fault circuit interrupter quickly trips, interrupting the flow of electricity and preventing electrical shock. Ground fault circuit interrupters are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code specifies the locations where ground fault circuit interrupters are required in Section 210.8. Arc fault circuit interrupters are designed to protect against electrical fires. An arc fault is a dangerous electrical arc that can occur in damaged or deteriorated wiring. Arc faults can generate a lot of heat, which can ignite nearby combustible materials and start a fire. Arc fault circuit interrupters work by monitoring the electrical current for the telltale signs of an arc fault. If an arc fault is detected, the arc fault circuit interrupter quickly trips, interrupting the flow of electricity and preventing a fire. Arc fault circuit interrupters are required in many areas of the home, including bedrooms, living rooms, and dining rooms. The National Electrical Code specifies the locations where arc fault circuit interrupters are required in Section 210.12. Proper wiring techniques are essential for electrical safety. This includes using the correct wire size, making proper connections, and protecting wires from damage. The National Electrical Code specifies the requirements for proper wiring techniques in Chapter 3. Overcurrent protection is designed to protect electrical circuits from damage caused by excessive current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip and interrupt the flow of electricity when the current exceeds a safe level. The National Electrical Code specifies the requirements for overcurrent protection in Article 240. Regular electrical inspections can help to identify potential electrical hazards before they cause problems. An electrical inspection should include a visual inspection of the wiring, outlets, switches, and other electrical components. The inspector should also test the grounding system, current fault circuit interrupters, and arc fault circuit interrupters. Any electrical hazards that are identified during the inspection should be corrected immediately. The National Electrical Code, often abbreviated as NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Codes series published by the National Fire Protection Association, often abbreviated as NFPA. While it is not itself a law, the NEC is adopted into law by many states and municipalities in an effort to standardize safe electrical practices. The NEC is updated every 3 years. The purpose of the National Electrical Code is to protect people and property from hazards arising from the use of electricity. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is a complex document, but it is essential for anyone who works with electricity to understand its requirements. The NEC is divided into chapters, articles, and sections. Chapters are the broadest divisions of the NEC. Articles are more specific than chapters and cover a particular topic in detail. Sections are the most specific divisions of the NEC and provide detailed requirements for specific installations. The NEC also includes tables and figures that provide additional information and guidance. The NEC is constantly being updated to reflect new technologies and changing safety standards. It is important to stay up to date on the latest edition of the NEC to ensure that your electrical work is safe and compliant. The NEC is available for purchase from the National Fire Protection Association and other sources. Many states and municipalities also make the NEC available online. The NEC is a valuable resource for anyone who works with electricity. By understanding the requirements of the NEC, you can help to protect yourself and others from electrical hazards. Grounding is a critical aspect of electrical safety, ensuring a safe path for fault currents. Bonding connects metal parts to equalize potential, minimizing shock hazards. Ground fault circuit interrupters protect against electrical shock by detecting small current imbalances. Arc fault circuit interrupters prevent electrical fires by detecting dangerous electrical arcs. Regular electrical inspections identify potential hazards, and the National Electrical Code provides standards for safe electrical installations. Understanding and adhering to these principles is essential for ensuring electrical safety in homes and businesses. When dealing with electrical systems, it is always best to consult with a qualified and licensed electrician to ensure that all work is performed safely and in compliance with local codes and regulations. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards.